Afla,
Present, Miss.
Ajlina, Amaya,
Present, Miss.
Atulya, Drishya,
Present, Miss.
Jyotish, Karthik,
Present, Miss.
Kavya,
Present, Miss.
Nachiketas,
Present, Miss.
Neeraj, Rangit,
Present, Miss.
Vaishnav, Vaishnav,
Present, Miss.
Anjali, Shruti.
Present, Miss.
Anjali is there?
Present, Miss. Present, Miss.
Okay. Ajmina is there?
Present, Miss.
Atulya is there? Not there. Jyotish,
Present, Miss.
Neeraj. Okay. Right. Good afternoon, all.
Good afternoon.
Yeah. Good afternoon. Okay. Yeah, I marked Neeraj. So let's start our class for today. In the last class, we were just discussing about the fourth layer of the TCP IP model or the OSI model, that is called it as the transport layer, right? Now, what was the main responsibility of transport layer? Drishya, what was the main responsibility of transport layer? Drishya is there? Yes or no? Drishya is there or not? Yeah, tell me, what is the responsibility of transport layer?
Process to process delivery.
Yeah, transport layer is responsible for process to process delivery, right? And I have told you about what do you mean by process. Process is nothing but it is an application program running on a host, and how they communicate is based on the client server relationship. And also, I have just told you what is port number. Now, what is port number? What is the importance of port number? In all the layers, you require an address to identify. If you want to deliver something, a packet, you require an address. So at the transport layer, that address is called as the port number. And also, I have told you about the socket address. Socket address, nothing but it is a combination of both the IP address and the port number. And I have told you the transport layer, it offers different types of services like multiplexing, demultiplexing, a connection-oriented service, a connectionless service, a reliable service, an unreliable service, etc. Right? Now, and also I have told you, you have got three important types of transport layer protocols. One is TCP, the other one is UDP, and the third one is SCTP. Right? TCP is nothing but transmission control protocol. It is a connection-oriented, reliable protocol. In one or two class or today itself, you will be studying about TCP in detail. That time I'll be telling you what is connection-oriented and what is reliability in an elaborate way. Right? And also UDP is nothing but it is a connectionless and unreliable protocol. Now, why it is called connectionless, why it is unreliable, and that we will be seeing in a minute, right? Now, today we will be just starting with the first type of TCP protocol, that is called it as the user datagram protocol. User datagram protocol. It is a connectionless, unreliable transport protocol. Connectionless means you don't have any handshaking between your sending and receiving entities. The packets in the transport layer, you can call it as segments, right? You will be calling it as segments. And if you want to deliver the segments or sending the segment, you don't have any handshaking that is happening between your sending and receiving entities, right? So it is called it as a connectionless protocol. And also it is called it as an unreliable protocol. Unreliable protocol means you don't make use of any acknowledgement process. So here the acknowledgement of data is not holding any significance. So until and unless you are not receiving any acknowledgement, you cannot always perfectly tell that your data has delivered to the destination perfectly, right? So you will be telling it as the UDP is a connectionless and unreliable protocol, right? Now, it is a very simple protocol. First I told it is connectionless, it is unreliable, and it is a very simple protocol. Now, where it can be used. So if a process wants to send a small message, and if it does not care much about reliability, you can make use of this UDP protocol. Understanding? If you are sending a small message and you are not worried about the reliability of that, in such cases, you can make use of this UDP protocol, right? Now, what it does is it takes the messages from the application process, right? You are getting the from the application layer. It is forwarded towards the transport layer in case of TCP IP model. Now, what it does is it attaches its source and destination port numbers, right? And what is the importance of port numbers there? You want to do the multiplexing as well as the demultiplexing services, right? So I have told you different processes will be running in the source host as well as the destination host, and they will be identified with the help of port numbers, right? So UDP, what it does is it takes the messages from the application process, it attaches the port numbers, and what it does is it passes the segment to the network layer. So network layer is below that of the transport layer. So once it does, all the attachment is done, it will be passing that segment to the network layer, right? And also I have told you don't have any handshaking mechanism between your sending and receiving entities, right? And here acknowledgement is not holding any significance. You don't have any guarantee on the ordered delivery of data. You cannot be sure that the data are coming in the correct order. There is no guarantee that the data is reaching the destination in the correct order, right? Understanding what is UDP? UDP is a connectionless, unreliable protocol. Acknowledgement is not holding any significance here, and here it is. You don't have connectionless means each packet is treated independently. They can take their own path and reach us the destination. Maybe they'll be reaching, may not, they will be reaching at the destination. The thing is, you are just sending the data. You are not at all caring about whether it is reaching the receiver or not, right? So now, let's see what is the datagram format of UDP, right? The packets, UDP packets, you can call it as the user datagrams. Now you are having a fixed header field and you are having a data field, right? So this UDP packets, it consists of a header field and a data field. Now this header field, it is of 8 bytes. Now what are the 4 main parameters of this header field? First one is the source port number. Second one is the destination port number. Third one is the total length. And fourth is the checksum. You have to remember this user datagram format. The first field is header field is the source port number, destination port number, total length, and the checksum. Now, what is that source port number? This is a 16-bit information, and that is used to identify the source port of the packet. You want to identify who is the source or the sender. So, in order to identify that, the port number will be placed in that field, right? So, 16 bits. The meaning is the port number can vary from 0 to 65,535. Right? Now, the second field is the destination port number. Now, destination port number is used to identify application level service on the destination machine. Or in simple way, you can tell that it is used by the process running on the destination host. You will have a destination port number. You will have, if you want to identify to where you have to deliver your packet, now you require a destination port number. And that is being placed in that field, right? Now, the third field is the total length field. Now, total length is nothing but it is the entire length of the UDP packet. Total length is nothing but it is the entire length of the UDP packet. It includes the header also. Now, what is the total length including the header field? And that is being that length is specified in that field. And fourth field is called the checksum. You know what is the importance of checksum? It is used to detect errors over the entire user datagram. Right? So this is the packet format of UDP protocol. It has two fields, main fields. One is the header field, which is of 8 bytes, and the other one is the data field. Header, again, 4 main parameters you have got. One is the source port number, the destination port number, the total length, and the checksum. Understanding? I have told you about what are the importance of UDP protocol and what is the format of the packet. Understood? Yes or no?
Yes, miss.
Yes. Okay. So in altogether, I can tell that this UDP, it provides a connectionless service. So the meaning of connectionless, don't forget that connectionless means each user datagram sent by the UDP is an independent datagram. You don't have any relation. Suppose if you have a message, you will be dividing it into many segments. Now each segment, you will be just delivering it through different paths. Maybe the same path they will follow or different paths. But it is, you don't have a perfect connection from the source side towards the destination side. The meaning is the packet can take their own way and reach the destination, right? So user datagram, each user datagram is treated independently there. There is no relationship between the user datagrams. Suppose they may be coming from the same source process and they will be going through the same destination process. Then also you don't have any relationship between the user datagrams, right? And also as you will be studying in TCP, like connection oriented. Connection oriented means what is the main thing? You are establishing a connection, you are transferring the data, and you are terminating the connection. But here nothing is happening like that. There is no connection establishment and there is no connection termination. The meaning is the user datagram can travel on a different path. Right? So this is just a summary of the UDP operation, connectionless service and an unreliable service. Right? Now, what are the uses of UDP? First uses, it is suitable for a process that require simple request response communication with little concern for flow and error control. That is what I told. You don't worry about the error, don't want to correct the errors, or you don't require any reliability. So in such cases, you can make use of this UDP protocol, right? Now the second use is, it is used for some route updating protocols. Already we have seen the routing information protocol, and there you can use this UDP, right? Now the third use is, it is suitable for multicasting. You know what is multicasting. So these are some of the uses. And other uses is it is used in voice traffic. It is useful for live streaming audios and videos. See, when you are watching a movie online, you don't want any delay there, right? Now, what is the actual thing is happening is you are not caring about whether you are getting all the information. You want to get it in a faster manner. You don't want any delay there. So UDP is that type of protocol, right? So as a summary, I can tell UDP is an connectionless protocol, an unreliable protocol. It does not guarantee that each segments are received in order. It does not care whether the person hears you or not, right? And you don't have any handshaking between for the connection establishment or the connection, or you don't have any procedure to close the connection, right? So you don't have any way to know that your data has received the destination properly. But when you are comparing UDP and TCP, it is a bit faster and efficient than TCP, right? So these are some introduction about the user datagram protocol. So when it is asked UDP, explain the UDP protocol, then you have to write what is exactly UDP. Now, what are the services it provides? Now you have to write about the user datagram format, and you have to write about some applications or uses of this UDP protocol, right? So the format, the packet format, you have to remember, right? Understood? So the first type of transport layer protocol is the user datagram protocol, the one which is a connectionless, unreliable protocol. Connectionless, the meaning is you don't have any handshake to establish the connection, or you don't have any procedure to close the connection. And also I told you it is an unreliable protocol. You don't have any guarantee that you are receiving each segment. And also it is in the correct order, right? But it is faster and more efficient than the protocol. The other type of protocol, what you are going to see is the TCP. Understood about UDP protocol? Yes or no? User datagram protocol? Atulya? Today all are present, I think. Okay. Atulya?
Yes,
Understood. Okay, right. Now, so the next type of protocol, what you are going to see is called it as the TCP, that is the Transmission Control Protocol. Transmission Control Protocol. Now, you have got some important, services or the functions of this TCP. So first one is this TCP is a connection-oriented protocol. Very, very important, right? TCP is a connection-oriented protocol. The meaning is it establish a connection. Establish a connection, right? Now after that, what you will do? The data transferring takes place, right? These are the three processes. Data transfer takes place and the connection is terminated. Connection is terminated. So these are the three phases that is happening for connection-oriented protocol. First one is you are establishing the connection. Second one is the data are exchanged. And the third one is the connection is terminated. But you don't have any physical connection here. There is no physical connection between two TCPs. No physical connection. Either that, what you are having? You create a virtual connection between two TCPs to send the data, right? Now, TCP uses flow and error control mechanisms. So you can tell that it is a reliable protocol, right? So these are some of the important specialties of this TCP. The first one is it is a connection-oriented protocol. Second one is it is a process-to-process protocol. It makes use of the flow control and the error control mechanisms. It makes use of port numbers. So I can tell that, so also it is a reliable protocol. Now, reliable protocol means it make use of an acknowledgement mechanism to check the safe and sound arrival of data. Right? But it was not in the case of UDP. You are not at all worried about, in sending the acknowledgement, right? But here they use an acknowledgement mechanism so that all the datas, they are arriving in order, and also all the datas are arrived also, like all the segments, it will be reaching the destination, right? Now, you have got some TCP services. The first type of TCP service is process-to-process communication using port numbers. I have told you the importance of port numbers, and TCP services, they make use of that, right? Now, the second type of service what TCP provides is stream delivery service, or you can tell that it is a stream-oriented protocol. Now, what is this stream-oriented protocol? So this, you can just see a diagram here. Now, what it does is it allows the sending process to deliver data as a stream of bytes. And also it allows the receiving process to obtain data as a stream of bytes. So what TCP does is it is creating an environment in which the two processes are connected. And that is connected, I have told you, a virtual connection or imaginary tube is created so that they carry data across the internet. So you can see you are having a sending process, you are having a receiving process, both are virtually connected, or you can tell that imaginarily connected through a tube. And here the sending process, what it will do, it will deliver the data as a stream of bytes. And the receiving process also, they will obtain data as stream of bytes. Okay, so in short, you can tell that the sending process, it produces the stream of bytes, and the receiving process consumes them. Right? Sending process, what they will do is they will produce or write to the stream of bytes, and the receiving process consumes or reads from them. Right? So that is the one type of service that the TCP provides. It is a stream-oriented protocol. Okay. So the next one, what I told is sending and receiving buffers. You have got sending and receiving buffers. Now, what is the concept of this? So sending and receiving process, you have a sending process, you have a receiving process also. Then the meaning is you are writing as well as reading data, but they are not at the same speed. You have to write your data, and from the receiving process, they have to read the data, but they are not usually occurring at the same speed. So what TCP requires is it needs some buffer for storage. You can just see in the diagram here, right? So you can just see you are having a sending process here, a buffer, and also at the receiving process, you are having a buffer. So you have two type of buffer, sending buffer and the receiving buffer. Now, how they are implemented is they are implemented in the form of a circular pattern, a circular array pattern. Right? Now, usually this buffer, you have here, the two buffers, it has been splitted into 20 bytes actually. When you count this, you will be having 20 bytes here. But usually, normally it is not like that, 20 bytes, just for an example. The author has given it as 20 bytes, but usually it will be more than thousands of bytes depending on the implementation. Right? Now, what happens at the sending side? So at the sending side, the buffer, when you are looking into the buffer, you have got three different chambers here. One is three types of chambers. You can just see in three different colors, you can see. One is white in color, one is gray in color, and one is pink in color. Right? Now, what does this indicate? So actually, this one type of chamber, that is the white section, they are the empty chambers. And empty chambers means they can be filled by the sending process. If you want to put your data and then you can put it in the empty chamber, which is white in color. Okay, so white section contains empty chambers that can be filled by the sending process. Right. Now the next chamber is the gray chamber. Gray area holds bytes that have been sent, but they are not yet acknowledged. Already the data are sent, but you didn't receive any acknowledgement from the receiver side. So they are kept in that buffer. Okay, so TCP keeps these bytes in that buffer until it receives an acknowledgement. Right? So that is the second area, gray area. Now the third area is the colored area. Now they contain bytes to be sent by the sending TCP. The bytes which are not sent, which are about to send, they are pink in color, or the colored area occupies that. Right? Now, once the gray chambers are acknowledged, the chambers are recycled and they are available for the use by the sending process. So once you get an acknowledgement from the receiver side, they can again accept the data. They can use by the sending process again. Okay, so that is at the sender side. So I repeat once again, you are having sending and receivers. TCP supports sending and receiving buffers. And what is the importance of buffer is you are not, I have told you, you are having a sending process, you are having a receiving process, right? You and all these data, they will be forwarding as a stream of bytes. So sending process will be produces the stream of bytes, and the receiving process, it consumes them. So the writing and reading of the data, that is not taking place at the same speed. So what TCP requires, it needs a buffer for storage. You have got two types of buffer here. One is sending buffer, other one is the receiving buffer. Now, once you look into the sending process side, you can have, the buffers can have three types of chambers. You have a white colored section, a gray colored section, and a colored section. Now, white colored section, they are nothing but the empty chambers. They can be filled by the sending process. Now, the gray colored chamber, they are nothing but you have already sent the data, but you have not yet received the acknowledgement. Now, colored area is they are the data that are about to send, right? So once you receive an acknowledgement from the receiving side, that gray area can be used for the sending process. Now, look on to the receiver side. Here, receiver side, you have only, it is divided only into two chambers. One is the white colored chamber and the other one is the pink color or the colored chamber. Now again, white area, what it occupies is, they contain some empty chambers to be filled by bytes receiving from the network. So once it receives the data, they will be occupied in that white colored area. Now, colored area contains received bytes that can be read by the receiving process. Okay, that is ready for reading process or consuming. So that is kept in that pink colored or the colored section. Okay, so when a byte is read by the receiving process, the chamber is recycled and they will be pulled to the, you are having empty chambers again. Okay, so once it is about to read by the receiving process, then that is the concept of recycling takes place. That means they will become white chambers. Now again, when it is once it receives the data, then they will be moving into the colored section because it is ready for read by the receiving device. Okay, so these are the type of sending and the receiving buffers in TCP. Understood? This is the second type of service it provides. Okay, now the third type of service is Tcp segments. We have already studied about the important responsibility segmentation, right? Transport layer, the important function is segmentation. Now, what is the concept of that? Segments, I have told you, you will have a message, you will be having a number of bytes in that, you will be forming it into a packet, and transport layer, you can call it as the segment, right? Now TCP, what it will do is it will add a header field here. So you can just see here, you have a segment and your header field is attached along with the segment. Okay, and they will deliver that segment to the IP layer for transmission. Now the segments are encapsulated in IP datagrams and they are transmitted. So TCP segments, so the messages, they are divided into segments. You will have different types of segments, and for each segment you will have the header field attached. Okay, now they will be transmitting it to the network layer. At the receiving side, the reverse operation takes place. Okay, so this is the one type of service that the TCP provides. Now the other one is what it is. Here it is full duplex communication. You know what is full duplex communication, right? Now what is full duplex communication? Can anybody tell? What is full duplex communication? Yes. Who will be telling? Neeraj. What is full duplex communication? Neeraj is
transmission reception same time.
Yeah. Data can flow in both the directions at the same time. Neeraj is not there. Who all are not there? Neeraj and who is left? Trisha is there. Atulya, Afla, Achmina, Amaya. Trisha, Jyotish is there. Karthik, Kavya, Nachiketas. Then Neeraj is not there. Rangi is not there. Right? Okay. So what I was telling us, it will support full duplex communication. Full duplex communication means data can flow in both the directions at the same time. Then what I told us, it is a connection-oriented service and it is a reliable service. Right? So these are some of the services that the TCP provides. Now next we will see what are the TCP features. Altogether, everything is related also. So you specifically sometimes the question is asked, what are the TCP features and what are the TCP services? You should be able to write it. Okay. So first type of feature is it adds a provision for sequence number in the header field. It adds a provision for sequence number in the header field. So the meaning is TCP ensures that the data reaches the intended destination in the same order it was sent. Okay, so what it does, it adds a provision for sequence numbers in the header field. Right? So I have told you how TCP handles data. They will be handling data in the form of segments. Right? Now, what is a segment? A segment is nothing but it is a collection of bytes. Right? Now, the bytes of data are transferred in each connection and are numbered. Now, how that numbering takes place is randomly. You will be generating the number and you will be placing it. So once these bytes are numbered, what does TCP do? It assigns a sequence number to each segment. So sequence number for each segment is number of the first byte carried in that segment. You can just see the bytes of the data being transferred in each connection are numbered by TCP. The numbering starts with a randomly generated number. And you can see what is the sequence number it is given for each segment. So you can just see an example here. The sequence number, the range is varying from 10,001 to 11,000. So which is the first value of that range? That value is given as the sequence number for the first segment. That is the meaning of that. Now, in all together, what is the importance of that sequence number is that it is ensuring that the data reaches the destination in the same order, right? So it adds a provision. It adds a provision for sequence number in the header, right? Now, the second type of feature is it is a reliable protocol. Reliable protocol means it is dealing with the acknowledgement. So what the receiver does is always it sends a positive acknowledgement or a negative acknowledgement about the data packet to the sender. Now, so once it receives the acknowledgement, what the sender can understand, it can understand whether the packet has reached safely or whether retransmission should be done. Okay, so it knows that whether the data are arranged is reached the destination or it needs to resend it. So what it does is it make use of an acknowledgement number field in the TCP packet header. Okay, so that is the concept of reliable protocol. They make use of the receiver, they make it send an acknowledgement to the sender in intimating whether it has reached received the packet or whether the sender has to resend it. Okay, so they make use of an acknowledgement number field in the TCP packet. Now the third one is it offers full duplex service. That is what I just told. The data can flow both the directions at the same time. Now the fourth point is it is a connection oriented. Connection oriented means you require that connection is there between two remote points, and that should be established before sending your actual data. If I want to deliver the data, the first thing is I want to establish a connection. A virtual connection is maintained between the sending process and the receiving process, right? Now, the other type of feature is it provides error checking and recovery mechanism. Yeah, error control methods is present in that and provides end-to-end communication. End-to-end communication means it guarantees that the data reaches the destination and in the correct order. Okay, and also it provides flow control, congestion control, and quality of service. I will be just telling in the next class what is this congestion control and quality of service. Just understand now TCP supports or it provides congestion control and quality of service methods. Okay, and also it operates in the client server mode. So these are some of the features of the TCP protocol, right? So as a summary of today's class, I have just told you the two important protocols of the transport layer. One is the UDP, User Datagram Protocol, and the other one is the TCP, Transmission Control Protocol. UDP, it is a connectionless, unreliable protocol, right? You have got various uses of UDP. It is used for multicasting. It is used for live audio streaming of audios and videos where you don't want any delay to happen. You will be just sending the data and you are not worried about the delay. So wherever you want to have such requirement is there, you can make use of this UDP protocol, right? Now the next type of protocol, what we have gone through is the TCP protocol. TCP means it is a connection-oriented, reliable protocol. So two words I told, connection-oriented and reliable. You should understand what is the meaning of this. Connection-oriented means a virtual connection is established before sending the segments between the two TCPs, right? So once the connection is established, data are exchanged, and once everything is over, it is terminated. The connection is terminated. Now the second is it is a reliable protocol. Reliable protocol means the receiver always send either a positive acknowledgement or a negative acknowledgement, right? And so the sender knows whether the data has reached the destination properly or not. And they make use of sequence number also so that all the data reaches the receiver side in the correct order, right? So that is the other one type of feature. Then it provides end-to-end communication. It provides flow control, congestion control, quality of services, etc. I hope you understood these two protocols. Yes or no? Understood about UDP and TCP?
Yes.
Yes, okay. See, Neeraj and Rangid, inform them to tell.
ഞാനുണ്ട്
വിളിച്ചപ്പോ ഇല്ലായിരുന്നല്ലോ, എവിടെയായിരുന്നു?
അത് കട്ടായി പോയതാണ്.
നീരജ് ഉണ്ടോ ഇപ്പോ?